So today I am going to discuss about the chapter quantum physics, and in this chapter I will be discussing about the topic Schrödinger equation. Schrödinger equation has two types. One is time dependent Schrödinger equation and the second is time independent Schrödinger equation. In the previous video we have discussed about the time dependent Schrödinger equation, and today we will discussing about the time independent Schrödinger equation. So time independent Schrödinger equation indicates that the time factor t will not be there explicitly in this equation. In 1D classical wave equation is given by del square u divided by del x square is equal to 1 by v square into del square u by del square t. That is the first equation, where v is the velocity of the wave. Then we have to consider u is the function of xt is equal to psi x into ft. It is the second equation, and we will get this equation by the method of separation. If we will substitute 2 in 1, then we will get ft into del square psi divided by del x square is equal to 1 by v square psi x del square f into del t square. It is the third equation. Take one of the standard wave equation solution for ft, such as ft is equal to e to the power iota omega t. Then just we will derivative ft with respect to t. Then we will get del f by del t is equal to iota omega into e to the power iota omega t. Then we will do the double derivative of this, and we'll get del square f divided by del t square, which is minus omega square into e to the power iota omega t. E to the power iota omega t is fx into omega square, and just put the value of d square f by d t square in this third equation, and we will get ft into del psi by del x square is equal to 1 by v square psi x into ft into minus omega square, and just cut the ft and ft both side, and from 3 we will get this. And then we have to calculate the value of omega square by v square. This is an ordinary differential equation describing the special aptitude of a matter as a function of position. Then we have to calculate the total energy. Total energy is equal to kinetic energy plus potential energy. Kinetic kinetic energy is equal to half mv square, and we have to multiply m both with the numerator and the denominator, and potential energy is equal to v into x, and we will get this mv is equal to potential momentum, that is p. So we will get energy is equal to this and p is equal to this. Then by the de Broglie equation we will get the de Broglie wavelength, which is h by p, and we will put the value of p in this equation. Now we have to calculate omega square divided by v square. V is equal to lambda phi and omega is equal to this. Then we will get the value omega square by v square, which is 2me minus v divided by h cross square, where h cross is equal to h by 2 pi. Then substitute equation 5 in 4. Then from the equation number 4 we will get del square psi divided by del x square plus 2m by h cross square into e minus v into psi is equal to 0. It is the sixth equation, and this is the time independent Schrödinger equation, and this is the other form of this equation. Thank you.